Hi, it's MP the tutor again. And I thought I'd start off initially by looking at what is a rational number. Well, a rational number is just a number which can be written as a fraction of two integers. For example, 2 is a rational number, but so is 3/7, so is 0.45, so is 0.3 reoccurring, which is 0.33333333, so on. We can even have negatives here. -7 is also a rational number. But an irrational number, for example, could be pi, or the square root of 2. So square root of 2 is not rational. So the square root of 2 approximately equals 1.4142135623 And that number for the square root of 2 is a non-repeating sequence. So it doesn't actually have a sequence, it just goes on forever, not quite randomly, but there isn't a sequence to it. In the same, you could have pi. So pi, obviously you've got pi is not rational, because again, it doesn't have a repeating sequence, and pi approximately equals 3.14159265358 ... And I'm not memorizing this, I'm actually just looking it up, because it would be quite weird to memorize all these digits randomly. Now, when you've got surds, which is the square root things, we often want to rationalize the denominator. So they might have something like rationalize the denominator for, let's go for 24 over the square root of 3. Now, the reason we want to rationalize this would be especially in programming, or even in life. If you think about square root of 3, well, that approximately equals 1.7320580756. Now, personally, with that calculator, I wouldn't want to divide by that, because that would be a pain. And even multiplying by it is a bit meh, but I guess I could do it. Division, with that, no thank you very much. And it's the same with computers and programming. So a division might be 20th of the processing speed of a multiplication. And in fact, a lot of processors don't even have the ability to divide, because it's so slow, they've not even bothered putting the silicon involved, and they've actually just done, it can only do times, it can only do add, and it can't do division. So you'd have to convert it anyway if you were doing programming for division. Let's have a little look at this question. Well, I'm first going to just rewrite 24 over the square root of 3. And what we need to do is we need to get rid of that square root at the bottom of the fractions. And we can do that by timesing both top and bottom by root 3. So root 3 times root 3 at the bottom is just 3. And the top is 24 root 3. Now, if you're not sure on this sort of thing, do go back to the previous video, which is looking more at the surds and stuff like that. And then what you'll find here is you've got 24 over 3, which is 8 root 3. That's it. It's worth about 2 marks, or 1 mark. It's not worth that many marks for these rationalized ones like this. We could have, let's go for rationalize. Let's do 19 over the square root of 7. Well, that equals 19 over the square root of 7. I'm going to multiply that by root 7 and root 7, which gets you 19 square root of 7 over 7. Now that is rationalize. So you don't always have to simplify it down, but if you can do, so 19 doesn't divide by 7, and that is it. So I'll give you a tick, that's worth, again, a mark or two as part of these questions. So this next question is a little bit different to the last. We have 2 plus the square root of 2 at the bottom of the fraction, and 4 plus the square root of 2 at the top. Again, what we care about is the bottom, not so much the top. And what we have to do is we have to use something called the difference of 2 squareds. So it's the difference of 2 squareds. Difference of 2 squareds. So you can always look that up elsewhere. So we have 4 plus the square root of 2, and 2 plus the square root of 2 again. So it's like last time in terms of just rewriting the fraction first of all, but then what we end up having to do is we multiply the bottom by the same numbers, but we change the sign. So instead of being 2 plus the square root of 2, it's 2 minus the square root of 2, and at the top we have 2 minus the square root of 2. So when you multiply top and bottom of fractions, you have to do about the same thing. And then what I end up doing, I know it's called the numerator, so I just call it top, bottom, is we multiply out these fractions, or these brackets. So we have 4 square root of 2, 2 minus square root of 2, and we have 2 root 2, 2 minus root 2. So here we go, 4 times 2 is 8. 2 times root 2 is 2 root 2. 4 times minus root 2 is minus 4 root 2. And root 2 times minus root 2 is minus 2. So at the bottom, we have 2 times 2 is 4. And then you've got 2 times root 2 is 2 root 2. 2 times minus root 2 is minus 2 root 2. And root 2 times minus root 2 is minus 2. So what we end up having is we have 8 plus 2 root 2 minus 4 root 2 minus 2 at the top. And at the bottom we have 4 plus 2 root 2 minus 2 root 2 minus 2. Well, what does that get us at the top? We have 8 minus 2 is 6. And 2 root 2 minus 4 root 2 is minus 2 root 2. And at the bottom, we have 4 minus 2 is 2. And then 2 root 2 minus 2 root 2 is nothing. So what we end up having is no surd at the bottom of the fraction. So in theory, that's already rationalized. However, if we can divide them all by a 2, for example, if it's 3, then we would rationalize it simplify it by dividing it out. So 6 divided by 2 is 3, and 2 divided by 2 is 1. So we have minus just root 2. And this here is our answer. So the 4 plus root 2 over 2 plus root 2 is the same as 3 minus root 2. So this is then rationalized. We've got rid of that square root at the bottom of the fraction. Let's have a look at this next one. So we have a very similar thing, but this time we just have a number at the top. So we have 6 over 3 minus root 6. So what I'm going to do is I'm going to first of all rewrite it as 6 over 3 minus root 6. And then again, we multiply the bottom by the same 3, but then we have a plus root 6. A bit longer, bracket, and then the top is then multiplied by 3 plus root 6. Top, back to the same as last time. Top actually only need a single line across. So you have 6 and 3 root 6, or plus root 6. Some people like to write plus. And the bottom, boom, 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 boom. We end up with 3 minus root 6, 3, and plus root 6. Let's sort out the top. So 3 times 6 is 18. And 6 times root 6 is 6 root 6. So the top is 18 plus 6 root 6. So let's look at the bottom. We have 3 times 3 is 9. We've got 3 times minus root 6 is minus 3 root 6. Then we have 3 times root 6 is 3 root 6. And root 6 times minus root 6 is minus 6. So at the bottom we have 9 minus 6 is 3. And 3 root 6 minus 3 root 6 is nothing. This time then, we then can look at this, and it does actually simplify. You end up with 18 divided by 3 is 6. And 6 root 6 divided by 3 is plus 2 root 6. Because the 6 divided by 3. So that's it, rationalise. So the 6 over 3 minus root 6 is the same as that equals 6 plus 2 root 6. So what we're doing here is getting rid of that square root at the bottom of the fraction. You don't tend to be able to get rid of all square roots. And the main purpose really in real life would be in programming, probably, if you were designing a program so that you don't have to divide by horrible square root numbers. So we might have another question, a little bit of this, where we actually have a double bracket at the bottom of the fraction. Now, what I find easiest to do, first of all, is I'm going to expand out the brackets. So we have 3 and root 5, 1 and root 5. So 1 times 3 is 3. 1 times root 5 is just root 5, or 1 root 5. 3 times root 5 is 3 root 5. And root 5 times root 5 is 5. So the bottom there is in fact 8 plus 4 root 5. And at the top we have 1. And then we just kind of do what we did last time. So I'm going to put that back to the side. So we have 1 over 8 plus 4 root 5. And then we have basically 1 over 8 plus 4 root 5. We multiply the bottom by the same, but with a negative in the middle. 8 minus 4 root 5. And then 8 minus 4 root 5. The bottom, we have 8, 4 root 5. 8 minus 4 root 5. 8 times 8 is 64. 8 times 4 root 5 is 32 root 5. 8 times minus 4 root 5 is minus 32 root 5. And 4 times 4 root 5 times by minus 4 root 5. What we do here is we have 4 times minus 4 is minus 16 times by root 5 times root 5 is 5. So that's minus 80. So what we end up having is at the top of the fraction we've got 1 times anything is itself, so we've got 8 minus 4 root 5. And at the bottom, what do we have? Well, we have 64 minus 80, which is minus 16. And then the 32 root 5 over minus 32 root 5 turns out to be 0. Now that simplifies. So what we can do is, because it's a divided by negative at the bottom, we can actually take a negative outside our fraction. And then they all divide by 4. So the 4 goes there, and then you have 2, because 8 divided by 4 is 2, and then minus root 5. So that is it rationalised, where I've also taken the negative outside the fraction, and you can do that if you only have one thing at the bottom of the fraction. So why don't you have a go now? I'm going to put some questions on the screen from the textbook and see if you can have a go at rationalising them. If you're not 100% sure on things, it might be worthwhile going back to the previous video on the other parts of surds, including adding and subtracting surds and turning them into simpler forms. But have a go now, and then the answers will be on the screen in a moment. Well, hopefully you've had a chance to have a go, and you've paused, and now you're checking the answers out. And that's the end of chapter 1. Do feel free to go back to the other videos, or hopefully I'll see you in the future videos as well.